So in the last video, we got all the tools that we need in order to start writing Haskell. But before diving in on how to write proper Haskell programs, it's important to familiarize with the syntax itself and how the programming language works. So in order to do that, we will use GHCi, and we got GHCi when installing GHC. In fact, GHCi, which you type like this, is just a shorthand for GAC with the interactive option, and this will also start the shell. Before using GACi, if you launch the program in your computer, you most likely will not have these colors, and also the output will not be colored. And that's because I do have some configuration loading when launching GHCi, and I do have specified this configuration in my home folder into a .ghci file, and by typing :q you exit GHCi, and the same file I do use for the configuration you can find in this repository, and in particular is in the .ghc folder, and the file is the ghci.conf. If you copy the content of this file inside your home directory in a file called .ghci, this will be loaded when calling GHCi, or if you just want that file to be loaded, say in only one of your path, then you include a file called ghci.conf into a hidden folder called .gac. And what this file contains is just a bunch of Haskell code, and really here there are a lot of utility function, but the only thing that is changing the color are these three commands, and the .gaci file is code that you can execute in the GHCi shell. In case if you want to use my configuration, you can just copy this file that you'll find also on GitHub, and then run GHCi. So GHCi is an important tool for us, since when we will need to know more about some function or values that we are using, we can go here, and GHCi does a lot of commands and utilities that will help us have more information on what we will be using, and this should be your first place where to search for documentation and also to test what you are going to write. So the first command that we will need is the t command that asks for a type of a value, and if I ask for the value of q, Haskell will infer the type, since Haskell is a statically typed language, but it does also infer the types of a value if it is not specified. But when Haskell tries to infer the type, it will always go for the most generic it can find. And in fact, if we see here the type of the number 2 to be something like numpy, an arrow, and then a p, same something really complicated in reality, we'll have specific videos talking on what's going on here. But for the moment, we are only interested in the fact that the actual type is what's on the right of this arrow, and on the left of this arrow made with the equal, there are some rules. And what this type is telling us is just that these two can be anything as long as this anything is a number. In fact, these two can be an int, and we see that is evaluated without problem, but this two can also be a float, and we get a float in fact. And if we ask for the type, we now get that 2 is a float or is an int. And the fact here is not that 2 has changed its type, but both float and int are valid types that satisfy the condition that this type is a number. And when I force some value to be of some kind of type, what I'm doing is just going here and telling, hey, I already know what this p will be, so there is no need for you to be that generic, since this p satisfies the condition of being a number. So you can remove this, you can drop the constraint of p being a number and just replace this p with the type I'm giving now to you. Now, on top of being statically typed, Haskell does have also the feature of being able only to have data that is immutable. And this immutable data means that when declaring a variable, and we can of course declare a variable as every other programming language by giving the variable a name and assigning to that name a value. And when I say that Haskell does only have immutable data, I mean that I cannot reassign another value to a same variable. Actually, here on GHCi is allowed, but if we try to do the same on an actual file that will be compiled, we do see that here I'm telling to GHC or Haskell what type I want the next variable to be, and I want it to be an integer. So I can only assign integer, of course, now to x. But if then later in the code I want to change the value of x, I already get an error, and the error tells me that I'm trying to declare x multiple times, and that's because we cannot change data in Haskell, but we can only use data that we have to create new data. And this concept is actually something that is common in functional in programming languages that adopt the functional programming paradigm. Now, another useful command that we can use with GHCi is the :k, and this command stands for kind. In fact, types in Haskell can be grouped by their kinds, and if, as an example, I ask what is the kind of int, well, we get this asterisk, and if we ask what is the type of num, we get an asterisk and then an arrow that is telling us that when we provide something that is an asterisk to a num, we'll give back a constraint. So we know that int is an asterisk. What happens is if I provide int as an argument to num, we get back a constraint. We will see later in the course how this can be useful, but I just wanted to mention it. And also, I wanted to mention it in order to introduce the I, which stands for info command, which when used with something like an int will give us some basic documentation. And as I said before, GHCi can also be used as some kind of documentation, and info or :I for short can do exactly this. And this info command, as an example with int, is giving us some information on how the type int is defined. And we can also see as an example that we find an instance of int which comes from num, and in fact we can use num with int. But also these are some features that will have dedicated videos. So in this video we saw how to use GHCi, we saw some commands that are useful when using GHCi, and also are useful in order to get documentation about what we are using in our Haskell programs. Now, of course, since GHCi is an interactive environment for Haskell, we can also run Haskell code in order to test what we are doing. I didn't mention it, but it should be clear since it is very similar to any shell of also other high-level programming languages. And with these basics from the very next lesson, we are going to talk about function, which, as you can imagine, in a functional programming language are very important. In any case, I want to thank you for your time. If you liked the video, you should consider to subscribe to the channel so that you can keep learning with me. If you find the occasion to learn something new, you can support the creation of this content by delegating your data to Harmonic pool. But at the end of the day, the most important thing that you can do is to stay decentralized. So with that being said, I will see you in the next video. Bye bye.